Good morning, everyone, and thank you so much for being here. I know you could have been watching anything on your Netflix queue, but you're here with me, and I'm very grateful. My name is Abdullah, and this is my dissertation defense titled Distributed Interaction Design. So our time together this morning is going to be split into 6 major sections. First, I'm going to go back in time and tell you all about the foundations of my work. Then I will spend some time talking about the related work in my field and what was the motivation behind my own work. Then I will touch on the tools and methods that I've built that I have already proposed to my committee. But the majority of the time this morning is going to be spent on the applications of my work and what I did with the tools and methods that I've built. Moving forward, I will touch up on the impact of my work and then what I will be doing in the future. So starting off with the foundations, way back, this is a picture of my hometown, Baghdad. I was born and raised there, and I moved to the United States in 2008 when I was 19 years old. When I moved to the States, I finally had access to high-speed internet and proper technology, and I became sort of obsessed. I used my access to learn all kinds of things like writing code, taking photography, even cooking, and building my own custom furniture. Basically, I used the technology that I had access to now to fill any gaps in my knowledge, and there were a lot of gaps. So here's a funny example. When I started my academic journey at the Community College of Baltimore County, I was taking a chemistry midterm, and I came up across this question that was asking to select all examples of a homogeneous mixture. And the options were A, sugar water, and this is what sugar water looks like. B, air. Like I said, I'm a photographer, and this is an accurate picture of air that I took. And C was rocky road. Now, I imagine almost everyone on this chat listening to this talk, the same goes for my professor, thought of this when I said rocky road, the ice cream. Growing up in Iraq, I never really had rocky road ice cream, so I was sitting in my midterm kind of freaking out on top of the anxiety of taking a test, thinking like, how can the ground be a chemical mixture? And this typically happens, this is what I call a design fail. This happens typically when there is a gap between the designer and the user. So the designer of the test, my chemistry professor, didn't know that I never knew what rocky road ice cream was. And bad design is sort of everywhere. And if you don't believe me, just take a look. Right. So my work aims to avoid these blunders by demonstrating the following thesis statement: that using a custom-built platform to conduct distributed interaction design enables the creation and evaluation of guessable, learnable, and memorable user-elicited interactions from a large pool of online participants in a timely manner. So let me tell you a little bit about the background work and what motivated me to do my own work. See, in my academic field of human-computer interaction, or HCI, we try to bridge the gap between us designers and our users by involving them in the design process itself, a practice known as user-centered design. And I've been doing research under the user-centered design umbrella for many years, and I focused mostly on accessibility and user-generated interactions. In the recent years, I've focused on distributed interaction design, the title of today's talk, in my dissertation. In my work, I've built tools, which, like I said, I have already presented to my committee in my proposal, and use my tools to do some applications where I'm going to focus the majority of today's talk on. Before I get started, let me just define what I think an interaction is so that everybody listening is sort of on the same page. I see an interaction between a human and a computing system to be that of three components. One, a user gives some kind of input to the system, and in response, the system does a function and provides some kind of feedback. Now, user input can be that of many forms. For example, it could be a press of a button, turning of a knob, or maybe a gesture, and so on and so forth. And in response, the system can give visual feedback, auditory feedback, haptic, olfactory, or gustatory. I think we're a little ways away from those two, but I digress. So following this breakdown, in my work, I use a method known as end-user elicitation to design interactions. And the way this method works is we typically invite actual users to a lab and show them a prompt of a computing function. Then we would ask them to propose the action they would do to trigger that function that feels the most natural and intuitive to them. Over many users and many proposals, we start seeing themes emerging, and we find the action with the highest consensus among our participants to implement in whatever system we are designing. Now, this is not really a new practice. Actually, the earliest example I was able to find was this paper from Good et al. Back in the 1980s, where they used this approach to design a user-driven interface for command line key terms. This method, however, took a huge leap forward in 2009 when Robert et al. Wrote a paper in which they formulated this methodology, introduced mathematical equations to measure consensus among participants, and also showed techniques on how to resolve conflicts in interaction proposals. And this study has been heavily cited with over 1,000 citations and over 300 studies replicating this method. And since 2009, we see that it has, as we see from this graph, that the trend is going up in the number of published studies using this method that keeps on increasing. And researchers have used it to design interactions for all kinds of applications like mixed reality, drones, and robots, and also used it to get insights into how the special populations would interact with certain technologies like individuals with disabilities and kids. So the elicitation method itself has inspired a lot of work on the best practices of it. So for example, this paper on how to reduce legacy bias in elicitation studies, I highlight this paper because it has influenced my own work a lot. And the way and what the authors mean by legacy bias is this pitfall in which participants in an elicitation study would propose interactions from existing technologies that might not be the best suited ones for newer technologies. So for example, if you want to select multiple items on a desktop, you might click and drag using the mouse, but if you're interacting with a fully immersive virtual environment, that might not be the best way to interact with that environment. And in this paper, the authors propose 3 different principles to combat this legacy bias in elicitation studies: the priming, production, partners. And the first 2 are highlighted because these are the 2 that I focused on in my own work. They call these principles the three Ps, and in the elicitation study literature, these three Ps have been a little bit questioned whether they work or not, so I sort of focused on that. So that's all great, but the elicitation study does have some drawbacks, or what I'd like to call opportunities for improvement. For example, the participant diversity, because typically these studies are run in a lab, you don't really get many diverse participants in it. So only people who are able and willing to come to your lab are the ones who get to participate in these studies. In addition to that, lab-based studies are typically limited to about 20-ish participants, which is not really desirable in elicitation studies, as there is work showing that interaction designs proposed by many participants were preferable to those designed by few, even if those the few designers were actually professional designers. The second drawback is analyzing these studies, especially the step of trying to find the interaction with the highest consensus, because we essentially need to subjectively compare every proposal to each other, to every other proposal for a given prompt. This process takes a lot of time and effort to do. And lastly, looking over the elicitation literature, a lot of these studies just ended by reporting a set of user-elicited interactions. There wasn't really a formalized method on how to evaluate these results to know whether or not the user-generated interactions really do work. Additionally, more recently, being in a physical space with strangers is kind of life-threatening. So to address these drawbacks, I looked to another area of HCI, which is called online HCI. And Lazar et al. Classify online HCI to be that of two major categories. First, online studies, and what online studies are the practice of crowdsourcing user research online. And the second area of online HCI is called human computation, which is the practice of using online crowds to perform a task that a computer alone is unable to do, or one person alone is also unable to complete. And online HCI have been prevalent in the recent years, and there are many examples of researchers using online participants to do things like label images, give fashion advice to blind individuals, and ideating at scale. So to capitalize on the success of elicitation studies and address the drawbacks I just highlighted, I decided to reach out from the lab to end users all over the world by creating an online platform. And I see my work and the platform that I created to be situated between prototyping tools and development tools. So if you're designing and building a new system, once you kind of have an idea of what that system looks like and what kind of sensors it has and everything like that, you would sort of do the work that I'm talking about in this dissertation before you actually invest the resources into building it, to make sure that you're building something usable. And from building my system, a 6-step process has come out of it, and I call it the distributed interaction design process. And this process has, like I said, 6 steps. The first one is set up the 4 pillars of a DXD study, then collect interaction proposals from actual users. Moving on, you would create an interaction set, and then test those interactions, these interactions quality. Then the 5th step, you would decide whether or not to repeat steps 2 through 4, and finally recommend interaction designs. Now, the first 2 steps of the DXD and step 4 all came out of my work in the 4th chapter of my dissertation, titled CROWDLICIT, a system for conducting distributed end-user elicitation and identification studies. In this chapter, I set out to answer 3 research questions, which are: how can I expand the reach of elicitation studies beyond the lab and reach a larger, more diverse pool of participants? What are the requirements for a system that translates the elicitation study to run in a distributed fashion? And what are the benefits and drawbacks of running elicitation studies in a distributed fashion? Then I also wanted to address the results evaluation part of the drawbacks of elicitation studies by asking the research question: How can I evaluate the guessability of the interaction proposals resulting from an elicitation study on a large scale in an efficient manner? Now, like I said, in the first step of DXD, you would set up the 4 pillars of a DXD study. And these 4 pillars are, first, you need to define the rules of engagement. It is necessary to explain to users, especially since you're not there in the room, what is the computing system in question? What does it look like? What kind of input does it accept? Typically, these rules are established as part of the instructions of a study, and it might sound something like this. Imagine you're interacting with a smart TV that accepts voice commands. So you would maybe include an image like this one, just to put them in the headspace of what they are about to interact with. Then you would need to establish a list of functions that your computer, that your system does. So for example, here you would say like the functions are pause, play, stop, next video, and so on and so forth. The other pillar is you need to figure out what prompt modality you need to use. Like how are you going to convey these functions and prompt your participants with? Are you going to describe them in text? So for example, in this example, it would be how would you get the system to go to the next video or something like that? Are you going to show images of the system state going from one state to the other, or use a soundbite if you're designing a like a smart speaker kind of system, or use an actual video with the highest fidelity possible? And the final pillar you need to set up is you need to figure out how you want to capture your participants' proposals. Do you want them to just describe it in plain text? Do you want them to record a video of themselves doing a certain gesture to give to you as an interaction proposal? So to incorporate these pillars and collect proposals from people all over the world, I built the CROWDLICIT system, which enables me to sort of crowdsource the elicitation study process. And here is how it works. Here we saw a person trying to design new icons for their new interface, and they were able to create that their study and incorporate all the 4 pillars and send it to actual participants wherever they are and get interaction proposals in the form of icon sketches, for example. To evaluate CROWDLICIT, I replicated an elicitation study designing voice commands and mid-air gestures to control a TV-based web browser. This was a paper by Morris that have been replicated a lot in the elicitation study literature. And what I did is basically took the same functions that Morris used and put it on CROWDLICIT as a list of prompts to get proposals from actual users. And I collected proposals from 78 participants recruited from Amazon's Mechanical Turk platform to create a set of interaction designs. Moving on to the 4th step of the DXD process, I wanted to evaluate the interactions resulting from an elicitation study. And to do that, I established the end user identification study method, and I established it in a way to be the reverse of an elicitation study. So basically, we get participants, and in the prompt, we prompt them with an action. So we show them, for example, a gesture, and then we would ask them to propose what function they think would be triggered in the system. So it basically has the same setup as an elicitation study, just what the users will be proposing is flipped as opposed to the elicitation study. And I put both my set of interactions that I got out of CROWDLICIT and Morris's set of interactions that she recommended in her paper through an identification study. And in the end, I was able to actually triple the number of participants in my elicitation study, and I did so in half the time. So Morris reported that she required 12 hours to run the participants and didn't report like how long it took to actually find the participants and schedule them and all that. While CROWDLICIT, I did all of those things in only 6 hours. And as a result of the identification study, it turns out that the interaction set that I got from the CROWDLICIT elicitation study was significantly more identifiable than the one recommended in Morris's paper. So I'm going to go back a little bit to the third step of the DXD process, which is creating interaction sets or analyzing the results of an elicitation study by figuring out which proposals are the same in order to find the proposal with the highest consensus. To do this, I turned to the field of human computation or crowdsourcing with a little bit of help from machine learning. And this third step was addressed in the 5th chapter of my dissertation titled CROWDSENSUS, Crowdsourcing Similarity Judgments for Agreements Analysis in End-User Elicitation Studies. And in this chapter, I asked 3 research questions that go, how can a crowd of online workers facilitate the similarity judgments for agreements analysis in end-user elicitation studies? And by using the crowd, what are the benefits, if any, in terms of cost and time compared to the status quo use of expert judgments? And how does the quality of the results produced by the crowd compare to those produced by expert researchers? And to give you another dose of techno and how CROWDSENSUS work, please enjoy this video. Right, so what we just saw there, that a researcher can either import proposals of interaction designs from CROWDLICIT itself or upload them manually, and then is able to put them to a crowd of workers online. And those workers would typically vote on the similarity of these proposal interactions. And then with a little bit of machine learning magic, the researcher would be able to get the results as grouped proposals by their similarity. And to evaluate CROWDSENSUS, I recruited 6 expert researchers. Those are researchers who have published elicitation studies before, and then gave them the same data set that I put onto CROWDSENSUS and 410 workers that I got from Amazon Mechanical Turk to both analyze the results of an elicitation study that I had done. And in the end, not only did I get results of the same quality from CROWDSENSUS as the ones I got from my expert researchers, but CROWDSENSUS was able to do this, the same task 4 times faster. So to sum up, I built CROWDLICIT as a tool to run both elicitation and identification studies online. And then I built CROWDSENSUS to analyze those results efficiently. I put both of these tools together into one platform called the Crowd Design Engine, available at thecrowddesignengine.com. And if you go to that website, this is what you see, where the platform provides sort of details on how to do an elicitation identification study, how to go through the steps of a DXD study, and have request access to the system to be able to use CROWDLICIT and CROWDSENSUS. So now moving on to the meat of today's talk, and I'm going to be talking about two projects in which I use both the DXD process and the tools that I built in the Crowd Design Engine to answer some research questions. First, I'd like to talk about our desktops, physical and virtual ones, and how our physical desktops have actually inspired our virtual ones. I really, really love this project. And the motivation for this work can be beautifully summed up with one picture. This is a tweet from somebody who said, in the I'm getting old department, a kid saw this, and there's a picture of a 3D, a floppy disk, and the kid said, oh, you 3D printed the save icon. See, in this chapter, I wanted to know what icons out there have actually some objects that are no longer in use in our daily lives that have been replaced by technologies, and what young adults would think about these icons, and have they interacted with the objects themselves or not? And to do that, I asked 3 research questions. What icons would young adults sketch to trigger computer functions currently associated with anachronistic icons? And how familiar are young adults with the objects represented in anachronistic icons? And how identifiable is a set of icons elicited from young adults? In addition to that, while I was doing this project, remember those legacy bias reduction techniques that I was telling you about that have been debated in the elicitation literature? I wanted to take the opportunity and investigate if the production principle influences user-elicited interaction design. And the production principle actually means that you would ask participants to propose more than just one proposal, and to sort of push them beyond legacy ones and try to unlock ones that might be actually more useful and beneficial to whatever you're designing. So to achieve my goal, in the first step of this DXD study, I established a list of prompts. And those prompts were actually a set of what I called plausibly anachronistic icons. There were 39 functions with 38 different icons. Zoom and search both had the same icon of the magnifying glass. And after that, I recruited 30 young adults from our campus to do an in-lab elicitation study. The reason I did an in-lab elicitation study is because I was doing this work in parallel as I was designing and creating the CROWDLICIT system, and it actually really gave me hands-on experience and the knowledge I needed to define what the requirements for the system are and how to design it properly. I gave my participants prompts like this one: draw an icon that pastes, and in response, my participants gave me sketches like this one that I used to finally make an illustrated icon. In total, I collected 3,590 icons, and going through them was a blast. And when I went through them, I actually put them all together based on their similarity to create a user-elicited icon set. This icon set had half of it was of new concepts, and the other half remained anachronistic. So as the end result of the elicitation study, my young adults kind of proposed the same anachronistic icon that is already associated with this function. Looking over the results, as far as the legacy bias reduction technique of production, If we ask participants in an elicitation study to propose more than one interaction design, does that have an effect on the results of the elicitation study? Turns out yes. By looking at the percentages of anachronistic icon proposals and their production order, and using a mixed logistic regression model, turns out there is a statistically significant effect on the decrease of anachronistic percentages as the production order increases. So more proposals, less anachronistic or less legacy bias proposals you get from your participants. Moving on to the fourth step of the DFD process to evaluate the set of icons I got. From my young adult participants, I did an online identification study with 60 new participants I recruited from Amazon's Mechanical Turk. And I found that 34 out of the 39 user-elicited icons were actually identified correctly in the identification study. And the 5 that were not, 3 of them had new concepts from as a result of my elicitation study, and 2 of them were actually anachronistic. Those are actual icons that you can find on the desktop that when I put them through the testing of an identification study, people failed to recognize their functions. In the end, I put this set of icons as a design recommendation that included icons that were anachronistic by elicitation, new concepts, and a couple that were anachronistic by identification. And by that, I mean, at first, as a result of the elicitation study, these icons had new concepts, but they were not successful. They were not identified successfully in the identification study, which led me to sort of revert them back to their anachronistic one because it was more easily identifiable. The main takeaway is that we have about 20 icons that sort of are in need and for new concepts to be designed for them. And there were so many other interesting findings in the study, like for example, 22 out of the 38 objects represented in anachronistic icons were never used by the young adults I had in my study. Unfortunately, I don't have the time today to go through all these results, and actually the results of this study is currently under review for the International Journal of HCI currently. But I want to move on because I want to talk about movies.
What if
we
used movies
to design better?
Much better.
Technology.
Right. So what if we used movies to design better technologies? And the 8th chapter of my dissertation, titled I Am Iron Man, priming with sci-fi videos improves learnability and memorability of user-elicited gestures. In this chapter, I set out to explore another one of the legacy bias reduction techniques called priming by asking how does priming influence user-elicited interaction designs? And priming is a technique that we borrow from the psychology literature that dates back to the 1950s by presenting participants with some kind of primer before they start a task and to see if that primer influences the performance of the task. In addition, I wanted to answer a few questions to expand the 4th step of PhD, which is evaluating the quality of the interactions. And those questions were, how can I evaluate the learnability of interaction proposals resulting from an elicitation study on a large scale in an efficient manner? And how can I evaluate the memorability of the interaction proposals resulting from elicitation studies on a large scale manner, in an efficient manner? Finally, I wanted to answer the question, how can I create gestures for mixed reality environments that are guessable, learnable, and memorable? To do my priming, I drew on the bidirectional relationship between science fiction and HCI. There are many examples in the literature of how science fiction and HCI influence each other. For example, Schmidt et al. Mentioned this anecdote of how Steven Spielberg actually worked with HCI researchers from MIT on the design of the interfaces shown in his movie Minority Report. And it also goes the other way around, as Mugen et al. List a bunch of examples of how movies influence the design of technologies, like how mobile phones were inspired by the communicators from Star Trek. And like I said, priming is a technique that comes from psychology, and I used it in this particular project in two ways. First, drawing on the relationship between HCI and sci-fi, I decided to use a montage of sci-fi clips as a primer for the participants in an elicitation study. And the second way I used it is by drawing on this paper from the psychology literature by Sassenberg and Moskowitz, where they used the priming technique to put their participants in a creative mindset to reduce stereotyping. They did that by asking their participants to provide 3 examples where they felt they were creative before starting a task. So I borrowed that technique as well. But going back to the DXD process, I established a list of functions by choosing a video player in an augmented reality that had these 10 functions. So I set up my study by telling my participants to imagine they're interacting with an augmented reality interface that accepted their mid-air gestures. And then in a random manner, I presented them with these 10 functions, like what gesture would you do to play a video? What gesture would you do to go to the next video? And there were 3 more functions that were specific to an augmented reality, like in a video, in a view to a surface. Then, in the next step, I ran the elicitation study and collected the proposals from a total of 167 participants recruited from Amazon's Mechanical Turk. And I did that by setting up a between subject experiment that had priming as its factor with 3 levels. The first group of participants had no priming, which were the control group. The second group saw the sci-fi montage video before starting the elicitation study, which were the sci-fi priming. And the third group was the creative mindset, where they had to recall 3 times where they felt creative before starting the elicitation task. And my participants were randomly assigned to one of the 3 groups. Moving on to the third step, I created 3 sets of user elicited gestures, one coming from the control, one from the sci-fi, and one from the creative mindset. There was some overlap. For example, play, pause, and pin a view to a surface and bring the view into the field of vision all had the same exact gesture as the gesture with the highest consensus from my participants, which was a little bit surprising. But when I moved on to evaluate these 3 different gesture sets, at first I did an identification study by basically I reversed the process of elicitation studies, and I prompted my participants with a video of a gesture and asked them to propose what function they think would be triggered in this augmented reality video player. Looking at the results, there wasn't any statistical difference in the result of the identification study across the 3 groups from 50 new online participants. Again, I recruited from Amazon's Mechanical Turk. The cool part of the study comes later, or next now, when I expanded the 4th step of DXD to include learnability and memorability in addition to identification studies. And to do that, I once again capitalized on CROWDLICIT to run what I call a distributed learnability and memorability. To do so, I recruited 18 participants through Slack and posting on social media and stuff like that. And I contacted those 18 participants via video chat. I randomly assigned them to view one of the 3 gesture sets. Either they viewed the control or the sci-fi or the creative mindset. And once a participant was assigned to view a gesture set, they had to view each gesture video only once for all 10 gestures. And then they moved on to a link I sent them where they went to a CROWDLICIT interface where they had to perform the gestures from memory in a random manner. And then I collected those videos from them while I was still in contact with them and gave them feedback right away on whether or not they did, which gestures they missed and which gestures they got correctly. And if they missed the gesture, they had to go back, view the video for the videos for those gestures that they missed, do the same process again. and they kept doing it until they learned all 10 gestures. In the end, for the result of the learnability study, as far as initial learnability goes, and by initial learnability, I mean the number of gestures performed correctly out of the 10 gestures after viewing the video for the gesture only one time. The control had 65% of the gestures learned correctly after a single viewing, but sci-fi had 80%, and the creative mindset gesture group had 58%. Those differences were not completely significant. They were sort of trending towards significance with a p-value of 0.05. But for the overall learnability, which by that I mean the total number of gesture videos views required to learn all 10 gestures, like how many gestures how many times a video is viewed on average to learn a gesture in a given gesture set. The control had an average of 1.6. Sci-fi had a significantly lower average of 1.2, and the creative mindset had a 1.56 average number of viewings. Then, after a week of conducting the learnability study, I contacted my 18 participants again and asked them to once again perform those gestures from memory in a randomized manner, and they didn't have access to the training material whatsoever, so they had to sort of remember them after 1 week. As far as the results of the memorability study, only 43% of the gestures in the control gesture set were remembered correctly, 80% of the sci-fi ones were remembered correctly, and 73% of the creative mindset were actually remembered correctly. And those differences were also statistically significant. In the end, to sort of put my recommendation out of this study, I found that actually priming with sci-fi videos produced a gesture set that was more easier to learn and easier to memorize as well. And with that, I would like to move on to the impact of my work. Actually, last summer, I was down in Cupertino working at Apple's Advanced Development Group, and I was tasked with designing multimodal interactions for some secret project. I was able to actually convince my mentors to let me use the DXD process, and I was able to actually design those interactions were inspired by actual proposals from users, and built a prototype based on them and presented it to the senior vice president of AI/ML at Apple, which was a great achievement for me and my work. And so I want to touch on the advantages that the DXD process and the Crowd Design Engine offer me. First, they offer a large pool of participants. As I showed in the CROWDLICIT project, I was able to triple the number of participants from the study that I replicated by Morris, and also I demonstrated the access to the large pool of participants in the Ironman project, where I actually recruited about 8 times more participants than the traditional elicitation study of about 20 participants. Second, using the DXD process and the Crowd Design Engine allows me access to a geographically distributed pool of participants. So here in blue is highlighted there. Blue highlights all the different countries from which I got participants to participate in the work presented in this dissertation. Another cool application and very important one is inclusivity. At the moment, I am doing a project investigating wheelchair interactions with VR, and using the Crowd Design Engine actually allowed us access to reach out to our participants, especially in these times of social distancing. I am doing this project in collaboration with my colleagues at Microsoft Research and Carnegie Mellon University. Another advantage for my work is speed. In the CROWDSENSUS chapter, I showed that using the CROWDSENSUS system to analyze data from an elicitation study was 4 times faster. In the CROWDLICIT system, I tripled the number of participants and cut the time in half. And finally, in the Anachronism by Design, the Icons project, it took me and a master's student research assistant, about 6 months actually to recruit and schedule and run the 30 participants. But excuse me, using CROWDLICIT, I was able to run an identification study with 60 participants in only a single day, which was a huge testament to the work that I've done. All that to say that using a custom-built platform to conduct distributed interaction design enables the creation and evaluation of guessable, learnable, and memorable user-elicited interactions from a large pool of online participants in a timely manner. As far as my future research, as far as my future plans, I will be moving to New York City sometime once COVID let us, and next month I will be starting a position with Amazon to start their design services for enterprise and startup clients. And I will be using the DXD process and my platform to reach out to my vast network of researchers within the ACI community to collaborate on future projects and perhaps mentor some students who are working on research involving mixed reality technologies, accessibility, and perhaps the most exciting research area of all, which is the unknown. In the end, I would like to thank you all for listening as I'm losing my voice. I would like to thank my amazing committee and all my collaborators, especially those last 2 ones, and all of the funders for supporting my work. Thank you all.